Let's look now at some of the fundamental identities in trigonometry. We've already discussed how the sine and cosecant are reciprocals of each other. This is just a formal way of saying that. The sine alpha is the same as 1 over cosecant, and likewise cosecant is 1 over sine. You'll notice I've swapped the order of secant and cosecant so that I can have cosecant on top with sine, just to help us remember that they do go together. Cosine is 1 over secant, secant is 1 over cosine. Again, that's a reciprocal relationship. And finally, tangent is 1 over cotangent, cotangent is 1 over tangent. Now, you may have noticed just now I got lazy, and that's not a good thing to do. Tangent by itself has no meaning. It's like saying square root. Well, square root of what? So tangent, cotangent, cosine, all of these functions have to have some sort of argument. It's always tangent of something. So let's restate this last one. Tangent alpha equals 1 over cotangent alpha. Those are the reciprocal identities. Now let's look at another one that may not be as obvious. Tangent is sine over cosine. Tangent alpha is sine alpha divided by cosine alpha. To see that a little closer, let's look back at the definitions of sine and cosine. Sine of alpha is opposite over hypotenuse, and cosine of alpha is adjacent over hypotenuse. And if we take opposite over hypotenuse divided by adjacent over hypotenuse, invert and multiply, and we get opposite over hypotenuse times hypotenuse over alpha, or adjacent. The hypotenuses divide out and we end up with opposite over adjacent, which is in fact the definition of tangent alpha. Since cotangent is the reciprocal, we find that it's just cosine alpha divided by sine alpha. Those are the first two sets of fundamental identities. So how can we use these? Let's look at an example where we have sine theta equals 1/7 and cosine theta equal to 4 square root of 3 over 7. At this point we have no idea what this angle is, and we don't really care because we have this ratio. We know what the outcome of this function is, and that's good enough for us today. Let's determine the other 4 trig functions values given this information. The easy ones will be cosecant theta will be the reciprocal of sine theta, or the reciprocal of 1/7. And when you flip over 1/7, you end up with just plain old 7. Similarly, secant won't be too bad. Secant theta is going to be the reciprocal of cosine theta. So if we flip the 4 square root of 3 over 7, 4 square root of 3 over 7, when we flip that over, we get 7 over 4 square root of 3. And if we rationalize our denominator, we get 7 square root of 3 over 4 times 3 is 12. Let's look at tangent theta. Tangent is sine over cosine, so that means tangent theta would be 1/7 divided by 4 square root of 3 over 7. Invert and multiply 1/7. I told you you'd get good practice with your fractions. 1/7 times 7 over 4 square root of 3. Our 7's will divide out, leaving us with 1 over 4 square root of 3, which, rationalizing the denominator, would give us square root of 3 over 12. We could use the identity cotangent equals cosine over sine. However, I think at this point it would be easier to just grab this value for tangent theta and take the reciprocal of that. So the reciprocal of 1 over 4 square root of 3 is just going to be 4 square root of 3. I could have taken this version, but when I took the reciprocal of the square root of 3 over 12, I would have ended up with 12 over the square root of 3, and I would have had to rationalize my denominator again, and eventually, after a lot of simplifying, I would have ended up with 4 square root of 3.